Hello everyone, my name is MD Imrul Kayas Bhuyan.
And I am Noor Alam Bhuyaisham. This is our video presentation for Itech 2309 Software Engineering and Assignment.
In this assignment, we implemented the Village Builder game based on the system specifications. We designed in assignment 2, applying software engineering principle like MVC, design patterns, and test-driven development.
We will now demonstrate the core feature of the running application. Here is the main interface for Village Builder. At the top, you see the current turn, population, housing, available workers, and the player's resource along with the calculated per turn rate. The main area is the 30 to 30 game map, and on the right we have the action panel. Map cells have different states. Gray cells locked land. If I click one, the info panel shows locked land. Light green cells are unlocked and empty. Clicking on shows empty and unlocked land and enables the build button. Later, occupied cells will show building details here. Let's select the empty cell for this one from the drop down I will choose woodcutter hut and click build. Click build. You can see the call at 1516. Now change the color to the brown and shows the info panel updates and the others applications.
Now I would like to continue. Importantly, the players' resource have been detected, and according to the woodcutter hut's cost, which is 10 wood in this case.
The woodcutter hut needs a worker to produce wood. The info panel shows workers 0 by 1. We currently have one available worker. I'll select the hut and click assign worker. Now the info panel will be showing workers one by one, and our available worker count at the top has decreased to 0.
Actually, that matches the requirement for the hut, needing one worker to operate.
We can also unassign the worker by clicking unassign worker. The count reverts, showing 0 by 1 workers assigned and 1 worker available again. Now let's build a well on cell 15 and 17. Wells don't require workers. I will assign the worker back to the woodcutter hut. Notice the resource rate at the top now shows plus 20 wood per turn from the staffed hut, plus 20 water per turn from the well, and minus 1 bread per turn because our population is now 1. Now I will click turn button. Okay, the turn ended. You see the turn counter is now 2. Our wood increased by 20, water by 12, and bread decreased by 1. Exactly as the rates indicate the status indicated, the status message confirms turn 2 begins. Let's upgrade the well. Now I'll select it. In the info panel shows the current level and the upgrade cost. We have enough resources, so I'll click the upgrade building for this time.
My teammate Noor already showed so many things. So upgrading the well increase its level and water output. The cost for the next upgrade is also recalculated based on the new level.
Exactly, the info panel now shows the level 2, and the water production rate at the top has increased to plus 24 per turn. Yep. The game also allows trading resources. I can enter 20 in the amount field and click sell wood to gain 2 gold, or I can click buy wheat to spend gold and gain wheat, which is needed for the bakery item. And this demonstration covers the core functionalities like buildings, workers, management, resources production, and consumption, and turn progression and upgrading, addressing the main requirement from the of our assembly specification.
Actually, I was primarily responsible for the game's core model and logic. One key pattern I implemented is the Singleton pattern for the game class. Here you can see the private static game intense field, the private constructor preventing direct creation, and the public static game instruction method. This ensures the only one instance of the game class exists, providing a single consist point of access for the entire application, which the controller and UI rely on. We always try to follow the trace-driven development approach. For example, this is the best class for the woodcutter hut. Before implementing the production logic, I wrote this test. Test produce adds wood when this was assigned. It set up a player and a hut, assigns a worker using assign one worker, then calls the produce method. The assertion checks if the wood count increased by exactly 20. Importantly, there is another test. Test produce does nothing when assigned. Actually, this ensures the production only happen when a staffed rating this test first help with define the requirements precisely. Code worked correctly under different conditions.
For the testing the input controller, I used an integration testing approach as seen in the input control test.java. This controller's job is so simply delegate UI actions to the game model. For example, the test handle request success test first set up the game state by selecting a cell using the controller itself. Then it calls the controller's handle build request method. Finally, it asserts two things: the message return the matches to success matches from the game class, and that building actually exists on the map afterwards using assert not now. This varies to complete the chain of command.
In summary, we have successfully implemented the core features of the Village Builder game. Following our assignment 2 design, we applied MVC architecture, used design pattern like Slington factories, strategy, observed the employed test-driven development to ensure code quality and correction. Thank you everyone for listening and watching our presentation.
Thank you for watching.